Hello, we are Team 2813 The Gearheads. I'm Kyle.
And I'm Sierra.
And welcome to our 5th Java training video. On today's agenda, we have java.util, loops, and functional interfaces.
Okay, java.util. So in Java, you can import other packages into your code. So one way you can do that is with this method, which is basically you put your class that you want to import, and then you have your package name, and then you also use the keyword import to say that, to tell Java that you're importing something into your code. You can also do another way where you can use this to import everything. So use a little asterisk to import everything. You have your class again that you want to import. You have your package name, and then static basically just tells Java that you want to statically import something, which means you can access the static information from that class. And then you also use the keyword import again. So one interface that is in java.utils is collections, which basically is a group of objects. So here are some methods that you can use for collections. A list is also a type of collection, and it basically is a list of objects, or it's similar to an array, but it's better to be used when you're doing generics. And here are some methods that you can use for lists. A set. Okay, a set basically is a collection, but each element can only be contained once. So yeah, and then these are some hash set and enum set are two things that implement set. And hash set basically you can use any type of element, and then enum set is only for enums, and it's better to use this when you're doing enums just to be more clear and specific. So queue is also another type of collection, and it basically is first in, first out, which means that the first thing you put in will be like your head, and then it's kind of like a line where the first thing you put in is going to be the front of your line, and then as you add more things in, it's going to go behind that and so on. And these are some methods that you can use for it as well. And a deck. So a deck is similar to a queue, but instead you can actually remove or add things from the front and the back. So basically it's like a queue, but just you can do front and back. A map. Okay, so this interface is basically where you have a key and a value, and each key only has one value, but then values can also be mapped to multiple keys. And then optional is actually a class, and this basically represents a value that may or may not be there, which means that there's either a value or there's not a value. And these are also some methods that you can use for optionals. Okay, loops. So loops are very cool because it allows you to run the code a bunch of times, and that means that your code is going to be a lot more efficient and you don't have to rewrite the same code over and over again. So while loop is a kind of loop where it keeps running if it sees that a condition is true. So you have your keyword while and then the condition, and if that's true, then it'll run the code inside. Otherwise, it just doesn't do it. There's another type of while loop, which is called a do while loop, which is kind of similar to a while loop, but it's the opposite, where it runs the code first and then it checks on the condition. Okay, so for loop is similar to a while loop, but it's a lot more concise and it has a different syntax. So how it works is you have your variable initialization here, similar to the beginning of a while loop where you initialize your variable, and then you're going to check, each time it runs through, it's going to first check the condition here, and then if that's true, then it's going to run the code inside. And then once it's done running the code, it's going to run this expression here, and then it'll restart and then check the condition and then run the code and so on until the condition is false. And enhanced for is also similar to a for loop, but it's basically used to iterate through an array or a collection. Okay, so this is your programming project, your first one of the video. You're going to write a method that takes a list of messages that may or may not exist, and then print out every message that does exist.
We'll give you a couple seconds to pause the video and work it out if you want to, and we'll show the solution in a couple seconds. For the solution to this programming project, we're taking a list, which is this, of strings that might exist. Strings that might exist we're using optional because optionals are very good for representing things that might exist but might not. So then we just iterate over every optional value in it. So this is an enhanced for loop, so that is more concise. Check if the message is present, And if it is, then we know that this or else throw will always succeed. And then we just use printf to insert the string message into this spot around these quotation marks. And then we have a new line. And that's all there is to it. If any message is optional.none, this code block won't get called and it'll go to the next optional in the list. So that's the solution to this programming project. Next up, we've got functional interfaces. So, functional interfaces are just an interface that have one method that needs to be implemented. The way that this becomes useful is that Java has different mechanisms to easily create instances of functional interfaces that have that one method that needs to be implemented with some specific code in that method. And functional interfaces are very useful when you want to have some code and you want that to be run, but you don't want to run it now and you want to tell some other function, hey, call this code sometime in your method. And that's basically what functional interfaces do. Most functional interfaces will have the functional interface annotation, which just tells Java to yell at you if it has more than one method that needs to be implemented. And most functional interfaces in the Java standard library are in java.util.function package. And there are some elsewhere, and you can define your own functional interfaces. So first up, we've got consumer. Consumer is just a functional interface that takes a value, and it usually has side effects. So it is generic, and the generic argument, there's only one, and the one method that gets implemented is accept, which takes one type of the generic argument. And having side effects means that it changes some kind of state. And then there's also a default method to run this consumer and then another one. Function is a functional interface that takes a value and then returns the value. Generally, function does not have side effects, meaning that it does not change outside state. It has two generic arguments, the first one being the type of the one argument that is passed in to apply, and the other one being the return type. There are also default methods for running one function and then another. Next up, we've got supplier. Supplier is just a functional interface that returns a value without any inputs. So the one generic argument is the return of the method get that needs to be implemented. And then there's also more. And there are also like the same versions like by function, by consumer with the by prefix. That just means that it takes in two different values instead of one. Doesn't end up applying to supplier, as supplier doesn't actually take in values and you can't return multiple values in Java. So for by function, the first two arguments are the two things that get passed in, and then we have the return type. And then by consumer, the two generic arguments are just the two things that get passed in. There's also unary and binary operators. These are for you have some type and you return the same type. Unary operator of t is just equivalent to function of t, so it takes t and returns t. Binary operator is same as by function, so it takes two variables of type t and returns a variable of type t. Or returns an object, or takes in two objects of type t and returns one object of type t. There are also some functional interfaces for taking or returning primitives. For example, there's predicate, which has the method test that returns a Boolean. There's also some primitive type to some other primitive type function, which takes in one primitive and then returns another one. And then, yeah. Not all of these. There aren't versions for every single primitive. If you're curious about a specific primitive, you should look at the documentation and or just create your own if applicable. So, yeah. There's also versions without primitive a. For example, int function takes in some value, or takes in an int and returns something. There's also toInt, which takes in some value and returns an int. There's also the primitive type and then consumer, which just takes in a consumer, and then some primitive supplier, which just supplies a primitive. There are variants for double, int, and long in the Java standard library. And there aren't primitive variants for the by functions, so if you want those, then you can create your own. So, why is functional interfaces important at all? Well, you can actually create instances pretty easily. For example, function, as I said earlier, takes in some type, in this case, list of integer, and then it returns an integer. So then have this, then we can use a lambda. This part right here is a lambda. In this case, we're just setting it to a variable, but you could just put this as an argument to a function. So you have opening parentheses, your arguments, comma separated, and then closing parentheses, then this arrow, dash, and then greater than symbol. And then you have curly braces with your code block, and then, yeah. And then you have some code in this code block. And in this case, you just set a variable to 0 and then add up every value in the list and then return that. So the arguments can be implied. So you can put, like, for example, here we have int, and then we have val. Also, if you only have one line of code, then you can omit the curly braces and just have one line of code like this. Method references are useful if you want to say, I want to call this method. There are multiple different kinds. You can reference a static method. For example, there's integers toString method, which is static and it takes in a integer and returns a string. And then we have bounded, which calls an instance method on an instance that you provide. For example, we provide an instance of string, and then this method references to this length. So this will call the length method on this string object. Then we have unbound. Unbound is also for instance methods. So you specify the type and then the method, and then the resulting functional interface will take an object of the type, and then it will call the method on it, and then the rest of the parameters or return type will be the same as object. For example, here, object's toString method takes no arguments and returns a string. But since it's unbound, we take in an object that toString will be called on, and it will return the result of the toString call. You can also create a functional interface for a class constructor using new after the 2 colons, and then before is the type. And then you can also create an array constructor which will take in an int and return the array type using just int, the brackets, and then new. So yeah, there's nothing you can do with a method reference that you can't also do with Lambda. There is one obscure exception. You can look at like the Java specification 9.9-2 if you are interested. Link will be in the description. The difference between method references and lambdas. Both can do the same thing with the obscure exception that I mentioned in the last slide. Method references should be used where it makes the code clear, and lambdas should be used if they're shorter or if the parameter names make the code more readable. For example, there exists a static method on the function interface that returns a instance of function that just returns the input value. It is actually a lot shorter to use the lambda equivalent that just takes in the argument and returns the same thing, so you should usually use that instead of using identity. And sometimes it's actually shorter to use a method reference, but actually the names of the parameters of the lambda provide documentation that makes it easier to understand. And then sometimes it's just shorter and clearer to use method references. So you should use the one that makes most sense in your situation. For the final programming project of a video, write a method that takes in a list of objects that might exist and convert them to strings if they exist. Add these to a list and return them. As a note, the sizes of the input and output list should be identical. I can show you the solution in a couple seconds, so pause the video if you want to work on it.
Okay, now let's take a look at the solution for this project. So we have a method called convertToString, and it has a return type of the list of optional strings. And we also take in a list of optionals of any subtype of object. So now inside the method, we create a new array list called results. and that will be the same type as the return type. And now we have a for loop that basically goes through every single item in the list that we took in, and then takes in the for loop, then converts that item into a string, and then we add it to our array list. And once all the items are added, then we return our results.